Remember when calculating forecast error measures that the word mean, M-E-A-N, means average. Why is that helpful? Because in most cases that means that the name of the forecasting error measure pretty much explains how you calculate it. You can see that in this question. Given forecast errors of 5, 10, negative 10, 0, and 10, what is the ME? What's that stand for? Mean error? Well, mean means average. These are the forecast errors. Just average the errors. To answer this question, the only thing that you need to do is just average that particular set of errors. So I would say, okay, 5 plus 10 minus 10, careful, that's a minus, plus 0 plus 10, divided by, count them up, how many of them are there? There are, what, 5? Oh, okay, so the numerator all adds up to 15 divided by 5. That comes out to 3. Yeah, perfect, that's the answer. The mean error of that particular set of 5 forecast errors is 3. Now the next question, you see the capital M again, given forecast errors of 4, 8, and negative 3. So it's a different set of forecast errors. What is the MAD? The MAD is the mean absolute deviation. And then what is the MSE? Mean squared error. All right, one at a time. The MAD, now these actually are formulas, so I mean you can think of them as formulas if you want. Technically the formula would be sigma, summation, sum up the absolute errors, meaning drop the sign and then divide by the number of observations. Right, instead of just averaging the 4, the 8, and the negative 3, drop the signs so that what you're averaging is just 4, 8, and 3. 4 plus 8 plus 3 divided by 3. I get 15 then in the numerator, right, divided by 3. The MAD for this set of 3 forecast errors is 5. 15 divided by 3. The MSE is the mean squared error, or the average squared error. Again, average, square the errors, then just average them. It pretty much explains how you calculate it. Although you can think about it as a formula if you want. I'll copy it down as a formula. Mean squared error. Oh, you would, let me think, sigma, add up each of the errors squared. Then you would divide by the number of observations. Right. I just want to average not 4, 8, and 3, not 4, 8, and negative 3, but let's see, 4 times 4 is 16. 8 squared, 8 times 8 is 64. And 3 squared, 3 times 3 is 9. Average those numbers. All right, I would add them up and divide by 3. I get 89. 89 divided by 3. Right, or 29.67, that's the MSE, the mean squared error, for that particular set of errors. Now the next question is actually asking about that same set of errors, because it's 4, 8, and negative 3, but it's asking for yet another performance measure, the tracking signal. Oh, okay, tracking signal. That kind of is a formula. Its name doesn't really describe how you calculate it. The tracking signal is the ratio of the sum of the errors, just add them up, divided by the mean absolute deviation. Average the absolute values of the errors. Oh, all right, so for this problem, first off, in the numerator, I would just want to add 4 plus 8 plus a negative 3, or 4 plus 8 minus 3. In the denominator, I'd want to divide by the MAD. Actually, I have the MAD from, because it was that same set of errors from up here. The mean absolute deviation is 5. If you average just the absolute values here, that's 5. Right, well, that goes in the denominator. So I get that the numerator is 9, the denominator is 5. That reveals or yields that the tracking signal for those 3 periods is 1.8.